Hello everybody, this is Mrs. Snook with section 6.1, Solving Systems by Graphing. And we are going to solve systems of equations by graphing. And we're going to look at some special situations. So first off, before we get started, a system of linear equations means two or more linear equations that are modeled together. And what that means is that you have two equations, and each of them has both x and y. And your answer is going to be an x that works in both equations and a y that works in both equations. And so the solution to a system with linear equations is any ordered pair, so that's the x and the y, that makes all of the equations in that system true. So the x works in both and the y works in both. Now there are quite a few different ways to solve a system, and today we're going to focus on solving by graphing. So here is a system. Our first equation is y equals x plus 2, and our second equation is y equals 3x minus 2. So what we're going to do is we're going to graph each of these. And notice these are in a slope-intercept form. So all you have to do is plot the y-intercept and then use the slope to get a second point. So I'm going to graph our first one using black. So my y-intercept is a positive 2. I'm going to put a point there. And then slope is 1. So I'm going to go up 1 and over 1 and put a point there. I'm going to get my ruler and I'm going to graph this line. Okay, now switching to red for the second line. This time my y-intercept is at negative 2. And my slope is 3, so I'm going to go up 3, 1, 2, 3, over 1, 1, 2, 3, over 1. And then graph this line. Now the solution to this system is where those two lines intersect, which is right there. So if I read the coordinates of that point, I have x is 2, and then y equals 4. So my ordered pair would be 2, 4. All right, let's do another one. So again, here's our first system, y minus 2x equals 4. And our second equation is y minus 2 equals x. Now take a look at that first equation. That's not slope-intercept form. So let's go ahead and convert it to make it easier to graph. I'm going to add 2x to both sides, so I get y equals 2x plus 4. Now look at the second one. Y minus 2 equals x. Also not in slope-intercept form, so let's go ahead and add 2 to both sides, and I get y equals x plus 2. So now that I've got them in a form that's easy for me to graph, I'm going to go ahead and graph these. And I'm giving myself some extra points just to make it easier for me to graph. The minimum number of points for graphing a line is 2. That's all you really need. I do find it easier many times to go ahead and plot, 4, maybe 5 points. It just makes it so much easier for me to line up my ruler. All right, next one, y equals x plus 2. Okay. Here's this one. And then graph. And the answer is right there. That's the intersection where those two lines cross. And at that point, x equals -2 and y equals 0. So our answer is -2, 0. All right, so that's solving these systems. Now let's take a look at some special cases. So again, I have two equations. And each equation has an x and a y. So notice two equations and two variables. And I just want to point out that systems don't have to be only two. There can be more. So if we have three variables to solve for, say, x, y, and z, then we need three equations. If there's four variables, you need four equations. Now here in Algebra 1, we're just going to stay with two equations and two unknowns. But when you get to pre-calculus, you will be doing more. All right, look at first equation. That is in standard form. Let's go ahead and convert it to slope-intercept to make it easy to graph. So I'm going to come down here. I'm going to say 2y equals x plus 2, because I just added x to both sides. I'm going to divide both sides by 2. And that gives me y equals 1/2 x plus 1. So my first equation is y equals 1/2 x plus 1. My second equation is also y equals 1/2 x plus 1. So what's going to happen is when I graph these two, they're going to be the same line. So let's graph a 1/2 x plus 1. All right, I have some points. And now I'm going to graph the other one, which is also 1/2 x plus 1. Same line. So that means I don't have just one answer. So in a case like this, we have infinitely many solutions. So any point on that line would count as a solution to the system. Okay, let's look at the next one. Now we've got y minus 2x equals 2 and y equals 2x minus 1. Again, I'm going to label them 1 and 2. I'm going to do the first one in black and the second one in red. So let's convert the first one into slope-intercept form. I'm going to add 2 to both sides, so I get y equals 2x plus 2. And I'm going to graph that one. Okay, I've got a bunch of points. I'm going to grab my ruler. Just try to line it up as best as I can. Looks like I did a pretty good job. I hit all of those points. And now let's do equation number 2. This one has a y-intercept of -1 up to over 1, over 1. And let's line up this one. Check this out. These two lines never cross. There is no intersection. That's because they're parallel. And if you take a look at the slopes are the same. The only thing different is the y-intercept. So parallel lines, no intersection, which means this system is no solution. All right, everybody, that's it for today. Thank you for watching and have a great day.